Once again, good morning, students. I would invite Harun sir to start the session.
Thank you, ma'am.
Thank you.
Hello, students. Good morning.
Good morning, sir.
Good morning, Hashni. All right. Good morning, everyone. So I've sent DPP. I mean, the pending DPP. Not 7 questions together. You've done a couple of questions in that. We'll continue with that. Or do you have any doubts? Any specific doubts that you have got? We'll do.
Sir, can you explain the graph once again?
Which graph?
Last class.
Last class graph. All right. All right. I'll do that. That's it. Or anyone else has got any specific doubt? All right. After that, I'll complete the graph in some around 10 minutes and I'll go for these problems. Right? But you understand the graph again, not a problem. See, we were talking about two important graphs in AX graphs. Those two important graphs in mechanics are one is with positive slope, the other is with a negative slope. Correct? AX, A versus X. This has got some properties, characteristic properties, this has got some characteristic properties. So we already discussed both. So we started with this one because portrait of this one was easy. Portrait of this one is very beautiful but difficult. Yeah, sure. Sure. So how many of you want me to do this? How many of you have not understood last class? Raise your hand if you have not understood class. Okay. All right. Uh, there are new students here. Charanya and Nausheen are new, right? I mean, joined today. Mm-hmm. All right. Okay, Hashini. That's okay. Hashini, I'll do this. If you have a little confusion also, that's okay. I'm doing it.
Thank
So,
you.
no problem. Most welcome. So, I've got two AX graphs, which you have to understand very thoroughly. These are the two fundamental AX graphs in our syllabus. Now, whole of mechanics. No, this is one AX graph, this is one AX graph. From AX graph, I can relate graph to the physical situation. From this graph to the physical situation. But to picture, I'll have to draw Vx graph. Drawing Vx graph for this was easy because the equation of a circle was there. But for this, you get equation of a hyperbola. And I told you I'll teach you conic sections again. All right. Maybe in some extra class, I'll do it or tomorrow you're all convinced, tomorrow I'll take an extra class for only for conic sections. All right. Now, so let's start with this graph. This is the graph we did last class. Then we'll come to this graph. As a homework, I gave you this equation. And I appreciate Vignesh has immediately sent the homework. He sent it to the WhatsApp number. I don't know if Vignesh is present here or not. All right, so let's do this. So this graph, A is equal to minus x graph. All right, it could be minus kx also, But for some reason, for simplicity, I've taken a is equal to minus x. So the graph is a is equal to minus x. It could be minus k naught x also, or some number minus 2x, minus 3x, minus root 3x, anything. But for simplicity, I've taken minus x. All right. So that our equations will be little simple. That's it, only for that. Because if I take a is equal to minus x, I'll get circles. If I take a is equal to minus k naught x, I'll get ellipses. Because conic sections is not done in physics, I didn't do that. So simplicity is a is equal to minus kx. You understand, right? A is equal to
Yes.
minus kx చేస్తే కూడా వస్తుంది, but you'll get ellipses. Instead of circles, you'll get ellipse. So, but for simplicity, I've chosen a is equal to minus x. It could be anything. A is equal to minus k naught x అని ఏదైనా ఉండొచ్చు, ఇలా ఉండొచ్చు, ఇలా ఉండొచ్చు, ఇలా ఉండొచ్చు, ఇలా ఉండొచ్చు, ఎలా ఉండొచ్చు, but straight line. I'm talking about a straight line. All right. This is a very important graph in physics. Whole of mechanics. మరి SHM లో మళ్ళీ వస్తుంది ఇది. వర్క్ ఎనర్జీలో మళ్ళీ వస్తుంది ఇది. న్యూటన్స్ లాస్ లో వస్తుంది. All right. Now look at this, students. I've got a particle somewhere. I release a particle at origin. What happens to the particle? Because there is no acceleration, there is no velocity, it will stay there forever.
Yes, sir.
Now, if I release a particle at this point, at minus x naught, what will happen? Will it go towards right or towards left?
Left.
Right, sir.
Chudandi, how will you decide right or left?
Sir, acceleration is positive, sir.
Right. Who said left? Someone said left, now. See, that's okay to be wrong. It's absolutely okay to be wrong, but right, you're wrong. You should correct yourself. You should right, you're wrong always. All right. So, at this point, particle is at rest. Acceleration is positive. So, acceleration is towards right. So, particle will start moving towards right. So, particle goes towards right. It will go a little distance ahead. It will gain speed. Now, you still have an acceleration which is positive. Acceleration is reduced. Acceleration taggindi, but you still have an acceleration, because of which it will speed up. Further speed up. అలా స్పీడ్ అప్ అవుతూ ఆరిజిన్ దగ్గరకు వస్తుంది, బికాస్ యాక్సలరేషన్ ఇస్ పాజిటివ్ త్రూ అవుట్ ఫ్రమ్ minus x naught to plus 0. Minus x naught to 0, acceleration is all positive. So it's going on speeding up. Throughout minus x naught to 0, it's going on speeding up. When it reaches 0, acceleration is 0. Acceleration అయిపోయింది, vanish అయిపోయింది. But you still have velocity to that, because of which it will overshoot. Velocity will overshoot అయితే, let's say the velocity is v naught. Overshoot అయితే, it will cross this point, and once it comes over here, somewhere here, its velocity is towards right, acceleration is towards left. So it is retarding. So particle is retarding. Once it crosses origin, it is retarding. Till origin it was accelerating, after that it is retarding. By symmetry of the graph, I can say that from here to here, వెళ్తే ఇక్కడ x naught to 0 వస్తే 0 to x naught వరకు వెళ్తుంది. All right. Now ఏమవుతుంది, రైట్ సైడ్ ఆఫ్ ఆరిజిన్ ఇట్ ఈస్ గోయింగ్ టు విత్ వెలాసిటీ, సమ్ వెలాసిటీ ఓవర్షూట్ అయింది, వెలాసిటీ తగ్గుతూ 0 అవుతుంది. వై ఇస్ ఇట్ డిక్రీజింగ్? బికాస్ మై యాక్సలరేషన్ ఇస్ నెగటివ్, అండ్ దట్స్ వై యాక్సలరేషన్ ఇస్ ఇంక్రీజింగ్. యాక్సలరేషన్ నెగటివ్ ఉంది, ఇంకా మ్యాగ్నిట్యూడ్ లో ఇంక్రీజ్ అవుతుంది. సో రిటార్డేషన్ ఇస్ ఇంక్రీజింగ్. సో పార్టికల్ విల్ స్పీడ్ అప్ ఫాస్టర్, చాలా తొందరగా స్లో అయ్యి ఆర్ x naught దగ్గర ఆగిపోతుంది. ఆల్ రైట్.
Yes, sir.
Okay, now let us write equations for this one. This is the physical analysis corresponding correlated with graphical graph. The physical scenario is correlated with the graph. But now let us see the equations. I've got a is equal to minus x. So I can write, I can write a as dv by dt or v dv by dx. Right? So which one should I choose here? Because I've got x involved here, I'll use x here. Because I have to involve x here. To get v as a function of x, I cannot use this because there's a time here, and there's no time here. So I'll use v du by dx. Minus x. So dv is equal to minus x dx. Now I integrate. At x is equal to minus x naught, the particle is at rest, 0. At x is equal to x, particle's velocity is v. So I'll get v square by 2. Integral x dx is x square by 2. Integral v dv is v square by 2. Under limits 0 to v is equal to minus x square by 2 under limits minus x naught to x. ఇది నెగటివ్ సైన్ తీసేసి I'll reverse the limits. X to x naught చేసేస్తాను. So I'll substitute the limits now. Upper limit, lower limit. 2 cancel అయిపోతుంది. So v square minus 0 is equal to x square, sorry, x naught square.
X naught
Minus-
square minus x square.
Yes, thank you. Good. So then if I rearrange this equation, v square plus x square is equal to x naught square. I got this equation. If I look at this equation, there is an equation of a general equation of a conic special case ఇది. ax square plus by square plus 2gx plus 2fy plus d equal to 0 ఉంటుంది కదా. That's the equation
Yes.
of a conic. But conic లో a equal to b ఉంది, g equal to 0 ఉంది, f equal to 0 ఉంది. So this is a circle with center at origin. All right. So let's draw this circle. For different x naught, I'll get different circles. Hashini, is it clear? So far, so good?
Yes, sir.
All right, good. Which college are you from, Hashini?
Sentence Junior College, sir.
Oh, Sentence, all right. Sri Medha is your classmate?
Yes, sir.
Okay. All right. Now look at this. I've got,
సార్ సర్కిల్ ఎట్లా అవుతుంది సార్
నా ఈక్వేషన్ ఎలా ఉంటుంది? కోనిక్ ఈక్వేషన్ ax square plus by square plus 2cx plus 2dy plus e equal to 0. This is the equation of a conic. Any second degree equation in x and y is a conic. All right. Conics నేను చెప్తాను. For today you just accept that this is a conic.
ఓకే సార్
ఇప్పుడు దీంట్లో ఈ conic లో a b c d will decide, a and b will decide what type of conic, c and d will decide the location of the conic, c d e will decide the location of the conic, a
Yes,
and b
sir.
will decide what type of conic. If a is equal to b, then I'll have a circle.
Sir, can you say once again?
See, I've got ax square plus b, this equation, this is the equation of a conic, right? And if there is one delta b square minus 4ac, there is delta discriminant value which will decide what kind of conic it is. All right. And the value of c, d and e will decide the position of the conic. ఎక్కడ వస్తుందని. There is one more factor here, e xy కూడా ఉంటుంది plus f equal to 0. Don't worry about conic sections. I'll tell you conic sections for physics. Don't worry. But as of now, you accept that this is the equation of a conic. దీంట్లో a equal to b ఉంటే and xy term 0 ఉండాలి. a equal to b ఉంటే that's the equation of a circle. So I get v square plus x square is equal to x naught square చూస్తే what form it is? ax square plus by square plus 0 plus 0 plus 0 is equal to f.
F.
Right. So this is deciding the radius and this is the circle.
ఎస్ సార్
Now let us plot this circle for different values of x naught. X naught vary అయితే నా circle vary అయితేనే ఉంటుంది. And they're all centered at origin. So these are all
సార్
concentric.
ఎవరైనా
ఏంటి భావన?
సార్ అన్మ్యూట్ చేస్తే వేరే వాళ్ళు మీ స్క్రీన్ పోతుంది సార్.
ఓ సారీ నేను సెట్టింగ్ చేస్తాను జస్ట్ ఇప్పుడు పోదు. ఇప్పుడు పోదు. So if I've got Vx curve, Vx plane, x, V. V square plus x square is equal to constant square is nothing but circle with radius x naught. x naught meters లో ఉంటుంది, ఇది meters per second లో ఉంటుంది. ఈ distance కూడా x naught, but this will be meters per second. This will be minus x naught. All right. So ఇది minus x naught, ఇది plus x naught. So x naught 2 అనుకుంటే, so I'll have radius of 2, and this is radius to the circle. Radius 3 ది ఇలా ఉంటుంది, radius 4 ది ఇలా ఉంటుంది, 5 ది ఇలా ఉంటుంది. So as I go on changing x, I'll have a family of circles. Family of circles is a technical term. So which is having an equation. Sorry?
Portrait, sir. Portrait.
Yes. Portrait. Yeah, coming to that. I'm coming to that. Yeah. So Vx curve, this equation is nothing but equation of family of circles, concentric circles centered at origin. If x is equal to 0, that corresponds to the point origin, and that corresponds to the situation that particle is released at origin. Right? If I have x is equal to x naught, 5 and then 2, 3, 4, 5. Now this is the circle along which my particle is moving, not this circle, and this circle corresponds to the motion of the particle. If x is equal to 2, this circle corresponds to the motion of the particle. But general, it is a complete set of all the motions, possible motions of the particle. So, ఇప్పుడు నిన్న కూడా చెప్పాను, if I have someone's portrait, someone's sketch, pencil sketch, ఆ చూసి నేను క్యారెక్టరిస్టిక్స్ చెప్పగలుగుతాను. ఓకే, హెయిర్ స్టైల్ ఇలా ఉంది, స్పెక్స్ చేసుకుంటారు, ఓకే బియర్డ్ ఇలా ఉంది, ముస్టాష్ ఇలా ఉంది, నేను చెప్పగలుగుతాను. ఆర్ సమ్ హీ లుక్స్ లైక్ దిస్ ఆర్ షీ లుక్స్ లైక్ దిస్ అని. సో దిస్ ఇస్ కాల్డ్ ఎ పోర్ట్రేట్ ఆఫ్ దట్ పర్సన్, because this captures all of the characteristics of the person. Similarly, this Vx graph captures all the characteristics of the phenomena. What's the phenomena here? Particle oscillating. Particle is oscillating like this about origin, with more and more distances going away and coming towards left and right. That motion is captured in this Vx graph. All the properties of that are captured here. So that is why this if I look at this, I'll be able to talk about the motion completely. నాకు Vx graph ఇచ్చేస్తే నేను మొత్తం చెప్పగలుగుతాను. So that's why Vx graphs are called portrait of the motion. All right, they're called phase portraits technically. Technically, they're called portraits. Portraits అంటే PORTRAITS. So it's called a phase portrait. Portrait of the Vx graph is called a portrait. But Vx graph is not complete without arrow marks. Arrow marks will tell me the flow of the graph. Graph ఎలా flow అవుతుంది. For example, at this point, I have two velocities. Here ఒకటి, ఇక్కడ ఒకటి, ఇక్కడ ఒకటి, ఇక్కడ ఒకటి, ఇక్కడ ఒకటి, ఇక్కడ ఒకటి. But two velocities you cannot have at the same instant. ఒక instant లోనే two velocities are not possible. That doesn't make sense at all. It's impossible. All right, that doesn't make common sense also. All right, technical sense is SL కాదు, common sense కూడా valid కాదు అది. A particle cannot go in two directions at the same time. Right? So but I have got two velocities. That means they are not at the same instant. After some instant, some particle is coming back to that point. Right కి వెళ్తుంది, మళ్ళీ లెఫ్ట్కి వస్తుంది. Right. Right కి వెళ్తుంది V నాట్, లెట్స్ సే సమ్ V తో, మళ్ళీ లెఫ్ట్కి వస్తుంది V తో. సో రైట్ కి V వెళ్తుంది, లెఫ్ట్ కి V వస్తుంది. సో పార్టికల్ ఇస్ గోయింగ్ టువర్డ్స్ రైట్, మళ్ళీ కమింగ్ బ్యాక్. How can I say this from AX graph? Particle ఇక్కడ ఉంది, ఇక్కడ నుంచి వదిలేసాను, -x0 దగ్గర వదిలేసాను, స్పీడప్ అయింది, ఆరిజిన్ దగ్గర వచ్చింది, వెలాసిటీ గెయిన్ అయింది, యాక్సలరేషన్ 0 అయిపోయింది, బట్ వెలాసిటీ ఉండే, బికాస్ ఆఫ్ విచ్ ఓవర్షూట్ తర్వాత ఇట్ విల్ గో అహెడ్. When it goes little ahead, acceleration is negative, because of which it will start slowing down. Once it starts slowing down, it stops eventually. Once it stops, acceleration is there, acceleration 0 ledu. Stop అయిన తర్వాత acceleration ఉంది. So this particle will stop here, again return. Again this goes on forever, right? It goes on forever. If it goes on forever, how can I look at the Vx graph and say it goes on forever? I've got a loop. Vx graphs are loop for a periodic motion. Motion periodic ఉంది, so now Vx graph should be loop. In loop ఉంది కదా, so I've got particle is going like this, going back and forth, but Vx graph లో flow ఇలా చూపిస్తాము arrow mark తో. So arrow mark will tell me at certain instant where is the particle going. Arrow mark ఇలా ఉంది కదా, at this point I have to show where the particle is going. ఇక్కడ చూస్తే ఇక్కడ arrow mark ఇలా ఉంది, so particle will be going towards right, and then when it comes here, particle will be coming towards left. Now for this motion to be periodic, how should the Vx graph look like? It should be also a loop. Vx graph ఇలా ఉండకూడదు, ఇలా ఉండకూడదు. ఇలా ఉంటే ఏంటి, it is not coming back to the same position again. But ఇక్కడ చూస్తే V is this path flow, this flow is called flow. Flow is also a technical term. When we come to Newton's laws, we'll talk about flow. But right now, see, one interruption. This is called phase portrait. Portrait అర్థమైంది మీకు, phase portrait ఎందుకంటారు, న్యూటన్స్ లాస్ అర్థమవుతుంది. Alright, there is also a technical term called flow that you will understand eventually. Okay, but ఇప్పుడు ప్రస్తుతానికి flow ఉంటుందని గుర్తుపెట్టుకోండి, ఫుట్ నోట్ లో రాసుకోండి. The ones who are new here, I'll write some new technical terms or new terms which are to be discussed later in the footnote. So any new term you come across, or if I tell you that we'll come back to this again, or we'll relate this to something else again, you write that in the footnote. So right now you write this in the footnote. Phase portrait అని footnote లో రాసుకోండి. Wherever you have drawn this, in that page, footnote లో, I've got a page like this. Here you write down phase portrait and flow. All right. So when I talk about phase portrait and flow, you can come back to this page and think about it again in those terms. With that understanding, you can visit this page. All right. So that's the intention of writing footnotes. అర్థమైంది కదా కొత్త స్టూడెంట్స్ కి?
Yes, sir.
Okay, who is it? Nausheen. Hi, Nausheen.
Hi, sir.
Which college are you from?
I'm from Telangana
Which college? Telangana Model School,
Model School and Junior College.
Model School and Junior College. All right, good.
Sir, I've been not added in that group, sir. So that my
For the
friend is
sorry, what is happening? What is not added? Your email ID.
no, sir. My number is not added in that group, so that I'm not getting Zoom links. My friend is sending to me.
Oh, okay. You do one thing. You send your phone number to this chat box.
Okay, sir.
All right. Whichever number is to be added, you send that number in the chat box.
Okay, sir.
All right. I'll speak to the concerned person. Okay. Now look at this. So phase portrait లో that see, నేను చెప్పాను కదా, Vx గ్రాఫ్ నేను చూస్తే నేను మోషన్ ఎలా ఉంది చెప్పగలుగుతాను. నా Vx గ్రాఫ్ లూప్ ఉందంటే అది పార్టికల్ హాస్ టు బి పీరియాడిక్ మోషన్. ఎందుకు? పార్టికల్ ఇస్ స్టార్టింగ్ ఫ్రమ్ హియర్, ఇట్స్ గోయింగ్ లైక్ దిస్, అగైన్ ఇట్స్ కమింగ్ బ్యాక్, అగైన్ ఇట్స్ ఫాలోయింగ్ ద సేమ్ ట్రాక్. నా Vx graph is following the same track, so my particle's motion will be periodic and bounded. All right. Now Vx graph ఇలా ఉందనుకోండి, the story is different. Okay. Now, fine. So that's it. Vx graph, concentric circles, family of circles, which is called a portrait of the motion. It's called phase portrait. Phase portrait we'll talk about later. Phase we'll talk about what is meant by phase, we'll talk about it later. But it's called portrait of the motion. Now, this is for a is equal to minus x. We got circles. Let us now try for a is equal to plus x. Hashini, is it clear? Are your doubts clear?
Yes, sir.
Okay. So one extra class we'll take for conic sections. If tomorrow you are all convinced, we'll take tomorrow itself. Because again, we'll have no holidays in between. Holiday is the only possible day for us to have extra class. Okay. All right. Now, for ఏజ్ కూడా ప్లస్ ఎక్స్ చూద్దాం ఒకసారి. ఈ డ్రా చేయడం కాకుండా we'll just do the analysis again quickly, 2 minutes లో. I have a particle of a x graph like this. A is equal to x. For simplicity, I have taken a is equal to x. It could be a is equal to k naught x also, with k naught as some constant. Now, particle is released from here. What would happen? It will go towards right or left?
Left, sir. Left.
Left. Left.
Yes, sir.
How about others? What do others say? Hashini or
Acceleration negative ఉంది sir.
Right.
yeah, who is saying right? Okay. Why do you think it is right? Why do you think it is right? It's okay.
Sir,
Today's revision.
acceleration is
Huh.
negative, sir.
Huh?
It
So
goes to
acceleration is negative. It goes to
left, sir. Left.
right. That's left. So left is right. Left answer is right answer. So yes, you are right. Bhavna, Hashini, you are right. Others, I hope you have understood. Particle goes towards left. If I leave it at origin, what happens?
No change, sir.
It will remain there forever.
Yes, sir.
All right. If I leave a particle over here, what happens?
It will go to right, sir.
Right,
It
sir.
will go to right forever, to
Yes.
infinity. Right. Now, ఇప్పుడు ఏం చేస్తాను? Instead of leaving here, I'll project the particle with some velocity v0. అప్పుడు ఏమవుతుంది? What are the possible scenarios? v0 ఉంటే it will go, acceleration is towards left, v0 is towards right. So it will go retard, particle will retard.
Yes, sir.
సో కొంచెం దూరం వెళ్ళి ఆగి మళ్ళీ వెనుక వెళ్ళిపోవచ్చు. కానీ ఆగినాక వెనక ఎందుకు వస్తుంది? ఎందుకంటే ఆగినప్పుడు యాక్సిలరేషన్ నెగటివ్ అగైన్. సో ఇట్ స్టార్ట్ కమింగ్ బ్యాక్.
Yes, sir.
నౌ ఇఫ్ ఐ గివ్ లిటిల్ మోర్ వెలాసిటీ, ఇంకొంచెం ముంగట వెళ్తుంది. ఇంకా ఎక్కువ ఇస్తే వెలాసిటీ ఇంకొంచెం ముంగట వెళ్తుంది. ఇంకొంచెం ఇస్తే ఆరిజిన్ వరకు వస్తుంది. కానీ కొంచెం ఆరిజిన్ క్రాస్ చేస్తే ఏమవుతుంది?
రైట్ సైడ్ వెళ్ళిపోతుంది.
వెళ్ళిపోతుంది. సో if at all I have to target the particle to hit this point, if someone is standing here, I have to hit this person, I have to just cross origin. So my
Yes.
velocity should be sufficient enough for me to touch origin. Origin ki just cross cheste, I am done. My acceleration will take care of that. This one. So now
Yes.
look at this, students. Now motion is bounded or unbounded? Unbounded kada. Its side unbounded undi, its side unbounded undi. It's not periodic motion. అంతే కదా. మై మోషన్ ఇస్ అన్బౌండెడ్. ఇక్కడ వదిలేస్తే ఇన్ఫినిటీకి వెళ్ళిపోతుంది, ఇక్కడ వదిలేస్తే ఇక్కడ ఇన్ఫినిటీకి వెళ్ళిపోతుంది.
Sir.
Yes,
సో మోషన్
sir.
ఇస్ అన్బౌండెడ్. అండ్ ఇస్ ద మోషన్ పీరియాడిక్ లైక్ బిఫోర్? బ్యాక్ అండ్ ఫోర్త్ మోషన్ ఉందా ఇది?
No, sir.
No, right? So my Vx phase portrait cannot be a loop. If I give you two phase portraits, let's say, One phase portrait is this one. Option A లో ఇది ఇస్తాను. Option B లో సారీ ఆప్షన్ B లో ఇది ఇస్తాను. Even when you don't understand this face portrait, I can surely say this is not the face portrait for this motion. Why? Because face portrait is a loop here. For loop, it means it has to be an oscillation.
Yes, sir.
But this is not a loop. See, this is an unbounded curve. It వెళ్ళిపోతుంది curve. It's unbounded. So this can be possible for this one. ఓకే, నేను ఇది ఇంకా మాట్లాడలేదు. కోనిక్ సెక్షన్ తర్వాత ఇది డ్రా చేస్తాను. కోనిక్ సెక్షన్స్ చెప్పిన తర్వాత ఐ డ్రా హైపర్బోలా ఇన్ ఫ్రంట్ ఆఫ్ యూ. Till then, let's not touch hyperbola. Okay, now look at this. I've got two phase portraits possible. If I give you two options, and if I give you AX graph like this, by looking at the physical situation, I can correspond A the portrait, then Kenny. Because this is a bounded one, unbounded one, portrait also has to be unbounded curves. If this were bounded, my phase portrait is supposed to be loops. So for A is equal to minus X, my phase portrait is this one. A is equal to plus X, it could be this one. All right, I don't know, but two options is there. Then elimination though, ఇది eliminate అయిపోతుంది, ఇది ఉంటుంది. So this is the correct option.
Yes, sir.
Okay, now let us quickly write the equations for this. Then let's go for those problem solving. Okay, I'll just write the equation, leave the equation. సాల్వ్ చేశారా నిన్న ఈక్వేషన్ ఇచ్చినప్పుడు? ఇంటిగ్రల్ VDX is equal to ఇంటిగ్రల్ ADX అని ఇచ్చాను చూడు.
Yes,
సాల్వ్ చేశారా? అందరు
Sir.
చేశారా? రాసారా? జస్ట్ ఇట్ టేక్ 1 minute, no?
Yes, sir.
ఓకే, నాకు చెప్తారా ఈక్వేషన్ మరి?
Yes, sir. Yes, sir.
Okay, what is that? A is equal to X. So VDV is equal to X dx.
Yes, sir. Integrate.
Integration.
Integrate, right? Integration. From where to where? I'll plot the graph.
V to V naught.
No. That's not how you're supposed to say. That V to V naught is correct. But let's say I leave it at X naught. So I write at X minus X naught. My velocity is 0. That's how I'm supposed to read. Alright. Concept clear ఉంటుంది అలా read చేస్తే. When it is at minus X naught, velocity is, okay, I'll project it with velocity. V naught. Project చేశాను కదా నిన్న?
Yes, sir.
Okay. So ఇక్కడ project చేస్తే particle కి at minus X naught, its velocity is V naught. At some X, velocity is V.
C.
Now I'll integrate. V square by 2 under limits V naught to V is equal to X square by 2 under limits minus X naught to X. 2 gets cancelled out. ఇప్పుడు చెప్పగలుగుతారా?
V
Yes, sir.
square
Minus V naught.
minus V naught square is equal to
Okay.
X naught.
X square plus X naught square.
Plus or minus?
Plus
Minus.
Minus.
Mi-
Upper limit minus lower
Lower.
limit.
Yes, sir.
X square minus of minus X naught whole square.
Yes, sir.
Right. ఇప్పుడు x square టర్మ్ ఇలా తెస్తున్నాను, v square టర్మ్ ఇక్కడ తీసుకెళ్తాను. So I'll have v square minus x square is equal to v naught square minus x naught square. This equation is the equation of a rectangular hyperbola. Rectangular hyperbola అంటే 1/x గ్రాఫ్ చూసారా? వన్ బై ఎక్స్ గ్రాఫ్ చూసారా ఎప్పుడైనా?
No, sir.
మ్యాథ్స్ లో
No.
చూడలేదా ఇంకా? ఓకే, ఈవెన్ ఐ డెంట్ టెల్ యూ, నో. లైక్ ఐ జస్ట్ టోల్డ్ యూ, ఈ పవర్ ఎక్స్ చేశాను, పారాబోలా చేశాను, స్ట్రైట్ లైన్ చేశాను, అంతే కదా. 1/x చేయలేదు నేను ఇంకా. ఆల్ రైట్. సో దిస్ ఈక్వేషన్ ఇస్ ద ఈక్వేషన్ ఆఫ్ ఎ రెక్టాంగులర్ హైపర్బోలా. బట్ లుక్ ఎట్ ది స్టూడెంట్స్, ఇది v naught నా చేతిలో ఉంది, x naught నా చేతిలో ఉంది. సో ఇఫ్ ఐ at x naught, if I project with velocity v naught such that v naught is greater than x naught, అప్పుడు ఏమవుతుంది? This term will be positive.
Yes, sir.
If this is equal to v naught, x naught, అప్పుడు ఏమవుతుంది? My this term will be 0.
Yes, sir.
Yes, sir.
అప్పుడు నాకు పోర్ట్రేట్ ఎలా వస్తుంది? v is equal to plus or minus x వస్తుంది.
Yes, sir.
Yes, sir.
If V naught is greater than x, less than x naught, this is less than 0. Appudu I've got three possible scenarios: greater than x naught, equal to x naught, less than x naught.
Yes, sir.
So these three scenarios, after I teach you conic sections, we'll plot a phase portrait for this one. And the phase portrait is really, really beautiful. Little complex, but really beautiful.
Okay, sir.
Okay. And when we come into 2 dimensions, we'll also talk of the trajectory of the particle. 2 dimensions వచ్చినప్పుడు ఇది 1 dimension particle కదా, సో 1 dimension లో వెళ్తుంది particle. But if it is in 2 dimensions, how will the trajectory of the particle be కూడా మాట్లాడదాం.
Okay, sir.
Okay. Now let's go for that list. I just sent you.
Yes, sir.
Yeah. Nausheen, can you ask your friend to send that to you? I sent it in the group. So let's do a problem. Okay, let's do second one. First one already చేసాము. Third one చేసాము. Third one was this one. The third one was this case of a is equal to x. Second one చూద్దాం. V is equal to a root x అని ఇచ్చారు. Velocity of the particle moving in a positive direction of x-axis varies as v is equal to a alpha root x, where alpha is a positive constant. Assuming that at moment t equal to 0, the particle was located at x is equal to 0, find the time dependence of the velocity and acceleration of the particle. All right. So again, because there is a variable acceleration, a equation, variable acceleration, constant acceleration, I can just go for integration. Integration is a very powerful tool. Calculus is a powerful tool for me to attack any problem. ఇక్కడ ఏమి ఇచ్చారు? A is equal, sorry, V is equal to alpha root x అని ఇచ్చారు. All right. Please follow this example very carefully. ఈ alpha place లో gravity acceleration to, okay, చెప్తాను, wait. V is equal to alpha root x. Now I'll write V as dx by dt is equal to alpha root x. This one way I can write, right? And if I want acceleration, what I can do? Acceleration is nothing but v dv dx. అప్పుడు acceleration is equal to v ఎంత ఉంది? Alpha root x into dv by dx. Can you tell me what is the derivative of alpha root x?
2 root alpha root x.
No, alpha is a constant. So alpha comes out 1 by
Yes.
2 root x.
Yes, sir.
So 1 by alpha into 1 by 2 root x. So root x gets cancelled out. What am I getting? Alpha square,
Alpha square.
which is a constant. So acceleration is constant. We got it. Acceleration constant అంటే ఇది constant acceleration motion కదా, అయినగా ఇంటిగ్రేషన్ నాకు వచ్చేసింది. It's a constant acceleration motion. In fact, looking at this equation, we can tell it's a constant acceleration motion because I've got v square minus u square is equal to 2as. If u is equal to 0, my v is equal to root 2as, which is nothing but root 2a into root s. చూడండి, ఈ equation same ఉంది కదా.
Yes, sir.
So whenever you see v is equal to root x form, k root x form or alpha root x form, that's a constant acceleration motion. Integrate కూడా చేయడం అవసరం లేదు. Acceleration ఎలా వచ్చేసింది నాకు? I'll compare this one with v is equal to alpha by 2, sorry, alpha square by 2. నేను దీంతో కంపేర్ చేస్తాను. దేంతో? v square equal to root of 2as తో. So alpha is equal to root 2a. So a is equal to alpha square by 2. All right. Now let's go alpha acceleration. So one part of the question is done. But now I want position as a function of time. Right. Now I'll integrate this. So I'll have dx by root x is equal to alpha dt. I integrate. Limits ఎలా చెప్తాం మనం? He gave some condition. At t equal to 0, particle is at origin. So at t equal to 0, it is at 0. At t equal to t, particle is at x. ఇప్పుడు దీనికి ఇంటిగ్రేట్ చేయాలి. దీనికి ఇంటిగ్రేట్ ఎలా చేస్తారు? ఎక్స్ పవర్ n ఫామ్ లో ఉంది. But what is he asking us ultimately? Oh, time dependence of velocity అడుగుతున్నాడు, not position. Okay, let's find position also. Nothing wrong. కానీ time dependence of velocity అడిగితే ఏం చేయాలి నేను? I got acceleration. Acceleration is alpha square by 2. I'll write dv by dt is equal to alpha square by 2. dv is equal to alpha square by 2 dt. I integrate. Particle started from rest. At t, it is v. So v is equal to alpha square by 2 into t. కానీ మనకి ఇంటిగ్రేట్ చేయడం కూడా అవసరం లేదు కదా, ఇది కాన్స్టెంట్ యాక్సలరేషన్ మోషన్. v is equal to u plus at రాయొచ్చు. యాక్సలరేషన్ నాకు ఆల్ఫా స్క్వేర్ బై 2 వచ్చింది. v is equal to u plus at. Initial velocity is 0. A ఎంత ఉంది? alpha square by 2. So I just substitute that v is equal to alpha square by 2 into t. That's it. So I got v as a function of t. Acceleration వచ్చింది, velocity కూడా వచ్చేసింది. పొజిషన్ ఎలా రాస్తాను ఫర్ కాన్స్టెంట్ యాక్సలరేషన్ మోషన్? వాట్ ఇస్ పొజిషన్? x is equal to ut plus half at square కదా.
Yes, sir.
So u is 0, half into alpha square by 2 into t square. That's it. That's my variation of position. Velocity ఇచ్చారు, velocity ఎలా ఉంది? v is equal to alpha square by 2 into t. Acceleration is alpha square by 2. That's it. We got all the three equations of motion. Alright, that's the question he's asking. But second bit lo interesting question అడుగుతున్నాడు. He's asking what is the average velocity when it covers a distance s. So when it covers a distance s or half at square, I have to find the average velocity. How will I find the average velocity? Total distance traveled by total displacement by total time taken. In time t, what is the displacement? Half at square.
Yes, sir.
So
Yes.
total displacement ఎంత ఉంది ఇప్పుడు? Average velocity is total displacement by,
Total time.
yes, good, total time taken. Total displacement ఎంత వస్తుంది? Half alpha
Alpha naught
square by 2
by 2 into t
t
square.
square by total time taken t. ఒక t cancel అయిపోతుంది. I'll get
Yes, sir.
alpha square by 4 into t.
T.
That's it. That's the average velocity of the particle for when it travels for time t, when it covers a distance of half a t square. All right.
Yes, sir.
Okay. Okay, let's go for the next one, quick. We still have about 9 minutes. Which one shall we do? We'll do last second one. A particle having a velocity v is equal to v naught at t equal to 0 is decelerated at rate of alpha naught v square, alpha naught root v, where alpha is a constant, positive constant. After what time in distance will the particle will remain at rest? After what time will the particle come to rest? And what happens after rest? Once it comes to rest, will it move or not? Let's see. So I've got alpha a ఎంత ఇచ్చారు? A is equal to ఎంత ఇచ్చారు? Have you seen the question? Last second one. Our sheet lo last second one.
Alpha under root V, sir.
Alpha under root V. All right. So I can write what is required. When will the particle stop? Right. First, time. Where is it? Time and distance. First, time is now. See, I've got acceleration as a function of v. I can write acceleration as dv by dt or v dv by dx. Which one do I choose in this?
V dV by dx.
v dv by dx చేస్తే నాకు పొజిషన్ వస్తుంది. బట్ నాకు టైం కావాలి.
dV by dt.
రైట్. v dvx కూడా చేస్తాము. నెక్స్ట్ అదే చేద్దాము. సో dv by dt is equal to alpha root v. So dv is equal to, sorry, dv by root v is equal to alpha dt. I integrated. Now what do I integrate? Initial velocity ఎంత ఇచ్చారు? v naught at t equal to 0. So at t equal to 0, my velocity is v naught. At t equal to t, my velocity should be
0.
0,
Zero.
right? Right, that's right, 0. Because the particle is coming to rest. అదే నేను 0 ప్లేస్ లో v రాశాను అనుకోండి, ఏమొస్తుంది నాకు? t ప్లేస్ లో స్మాల్ t రాసి v ప్లేస్ లో v రాస్తే నాకు ఏమొస్తుంది? v as a function of t వచ్చేస్తుంది. But I don't need that. He is only asking me what time it will stop. So I will not get the whole function. Function తెచ్చి కూడా నేను చెప్పొచ్చు. ఓకే, at this point v equal to 0 పెడితే టైం వచ్చేస్తుంది. But that's waste of time. 2 steps waste అయితే. In exam we don't have time. So at t equal to capital T or capital T naught, my velocity will be 0. I'll get t naught from here. So ఇప్పుడు ఏంటి? How to integrate 1 by root v? చూడండి, root v కి డెరివేటివ్ 1 by 2 root v. రైట్.
Yes,
సో
sir.
దీనికి ఇంటిగ్రల్ ఏముంటుంది? ఇది కదా.
Yes, sir.
Yes, sir.
So if I multiply by 2 on both the sides,
It will be root v.
yeah. All right, I'll send the integral formula, then that's even more easier. Formula లేదు కాబట్టి ఇలా ఎక్స్ప్లెయిన్ చేశాను. మీకు ఫార్ములాస్ అన్ని తెలియదు, ఇంకా తెలియదు కాబట్టి. సో రూట్ v naught to 0 is equal to, oh, this is a deceleration. I missed a point. It's a deceleration. So it should be negative v. నాకు just magnitude ఇచ్చాడు, but he said it's a decelerating particle, na? Second line లో ఇచ్చాడు చూడు, particle being
Yes, sir.
is decelerated at a rate of this much. So it's really negative that. So ఇక్కడ కూడా నెగటివ్ ఉండాలి. So negative alpha naught by 2
Into t.
into t under limits 0 to t naught.
Yes, sir.
ఈ మైనస్ ఏం చేస్తాను? తీసేసి ఇక్కడ రివర్స్ చేస్తాను లిమిట్స్.
Minus 0.
0 to v naught అయిపోతుంది. మైనస్ ఇక్కడ తెచ్చాను, లిమిట్స్ ఇక్కడ ఇన్వర్ట్ చేశాను. సో ఐ సబ్స్టిట్యూట్ రూట్ v naught అప్పర్ లిమిట్ minus 0 is equal to alpha naught t naught by 2. So this is anyway 0. I've got v naught is equal to alpha square. Oh, నాకు టైం కావాలి. So I'll get 2 root v by alpha naught.
2 root
So,
v.
2 root v.
yeah, 2 root v naught by.
Alpha.
So that's my time it takes for the particle to stop.
Yes, sir. Yes,
But
sir.
look at this. Understand one thing, students. After the particle stops, what is the acceleration when the moment the particle stops?
Once again, sir.
The moment the particle stops, what is the acceleration of the particle?
Negative.
No, stops. V equal to 0 పెడతాను. What is the acceleration of the particle?
0.
0.
0. Particle is at rest and there is no acceleration. The particle will remain at rest forever.
Yes,
So,
sir.
ఈ పార్టికల్ వెళ్ళి ఆగిపోతుంది. అంతే, ఆగిపోయినాక అక్కడ మూవ్ కాదు.
Yes, sir.
Yes, sir.
రైట్. సో యాక్సిలరేషన్ నెగటివ్ ఉంది అంటే అది అర్థం కాదు, దట్స్ కమింగ్ బ్యాక్ అని అర్థం కాదు. ద మూమెంట్ ఇట్ స్టాప్స్, ఇట్స్ ఎ డ్రాగ్ ఫోర్స్. నేను చెప్పాను కదా, డ్రాగ్ ఫోర్స్, వెలాసిటీ డిపెండెంట్ ఫోర్సెస్ ఆర్ డ్రాగ్ ఫోర్సెస్. Drag force will always try to slow you down. All right, drag forces never speed up. Drag forces will always try to slow you down, such that the relative velocity between the medium and the particle is become 0. ఇక్కడ this drag force velocity dependent acceleration కదా ఇది. సో దీన్ని drag force అంటారు. drag force వల్ల ఇది acceleration వచ్చింది. Drag forces are velocity dependent forces which will which will retard the particle and will not accelerate the particle. They are retarding forces only. They are dissipative forces. Energy lose అవుతుంది అక్కడ. Alright. Okay, now let us find out the position. Yeah, position, someone said we can write A as v dv by dx now.
Yes, sir.
Okay, let us write that. Minus alpha root v integrated. When, oh sorry, I can't integrate yet. Root v ని ఇక్కడ చేస్తాను, dx ని అక్కడ తీసుకెళ్తాను. So that becomes v by root v is root v. Alright, one root v and v cancels, I get root v. Root v into dv is equal to minus alpha naught into dx.
Into dx.
Right. When x is equal to 0, my velocity is
V naught.
right, initial velocity. When x is equal to x naught, my velocity is
0.
why? The particle is stopping there. I want stopping distance.
Yes, sir.
Now I integrate this. Integral root v ఎంత వస్తుందంటే v power 1 by 2 plus 1 by 1 by 2 plus 1. v power n plus 1 by n plus 1. Alright, all integral formulas will give me today I'll send all the integral formula to you.
Okay.
Okay, sir.
Just one second, I'll just take this thing from you. Okay. So దీని ఇంటిగ్రల్ ఎలా ఉంటుంది? v power
3 by 2 by.
Yeah, 3 by 2 by 3 by 2.
3 by 2, yes, sir.
3 by 2. Is it Gayatri?
Yes, sir.
Hi Gayatri, you were silent till now. Chemistry class की join है वह ఏంటి?
No, sir.
Okay. So minus alpha naught x under limits v naught to 0, limit 0 to x naught.
Yes, sir.
Alright. ఇప్పుడు ఇది తీసేసి దీన్ని రివర్స్ చేస్తా లిమిట్స్. ఈ 3 by 2 ఇక్కడ పంపించేస్తా. So I'll have I substitute the limits now.
3 by 2.
So v naught 3 by 2 is equal to 3 by 2 alpha naught x naught. So x naught is equal to 2 v naught 3 by 2 or power 3 by 2 by 3 alpha.
Yes, sir.
So that is the stopping distance. E distance to stop a particle not come back. It will stay there forever. Currently ఆగిపోతుంది. Alright?
Yes.
So you are
Yes.
able to understand the class now?
Yes, sir.
Yes, sir.
Alright. Good. Everyone now? There are still more students who are not responding. Class లో అల్లరి చేయాలి. Silent ఉండకూడదు.
Sir, attendance form didn't send.
And form, okay, you have a chemistry class now? You attend in that time you can submit the attendance form. Alright?
Okay, sir.
Alright. Have a nice day. Thank you all. If at all there is an extra class, we'll message in the WhatsApp.
Okay, sir.
Alright. And Nausheen, I'll add your number to this group.
Okay, sir. Thank you, sir.
Chalo then. Bye.
Bye, sir.
Thank you, ma'am.
Yes, sir. Thank you, sir. Yes, students, now you can join the next session. Join the 6 to 9 session.